All right, with this question here, we're using the graph of f. So we're going to focus on the graph and not the table this time. It says evaluate the limit. A lot of times with these ones, it's going to end up being a L'Hopital's type problem, which if you remember L'Hopital's, that's going to be if it's like 0 over 0 or a plus or minus infinity over a plus or minus infinity. So if we do a quick check, I can see the denominator is going to end up being 0 when I plug -1 in. So I'm guessing it's going to be a L'Hopital's type thing. So what I've noticed they've been doing in these AP YouTube for my AP Calc BC class, they've been doing these separately and writing it out. So I'm going to start writing things like they do because I feel like it's easier to get full points. So we're going to do the limit of the top, and we're going to do the limit of the bottom here. So I'm just finding the limit of the denominator, because that one's pretty easy here. We get 0. And if I do the limit of the numerator, which is this, what I'm doing is I'm letting x approach -1, which would make this upper limit here 1, -1 squared. So if I do a direct substitution, I just end up with the integral from -3 up to 1 of our f of t dt. So that's just saying find the area from -3, and I always mark it here because it's only going from -3 to 1. It's easy to like continue on if you don't mark it as you're going. And if I look at that, this area below is the same as this area above. I don't even have to find the area of those triangles to see that. I can see that. So this is just going to give us 0. So I have 0 in the numerator and 0 in the denominator. So I can say, therefore, L'Hopital's applies. And you have to say, therefore, L'Hopital's applies, or you're not going to get your points for applying L'Hopital's. So now what we do to apply our L'Hopital's is we just do the derivative of the top, write it on top, and we do the derivative of the bottom and write it on bottom. So our bottom is just going to turn into 3x squared. The plus 1 will go away. And the numerator, to take the derivative of this, we're using the fundamental theorem of calculus. So we're going to plug the x squared in, and we get f of x squared. But then this is not like our usual just x there. So you have to make sure you do the chain rule and you multiply by the derivative of x squared, which would be 2x. So this is where we're at right now. And then you can do a direct substitution. So if we do a direct substitution here, we're going to have f of -1 squared to be 1 times 2 times -1. So I'm just going to say times -2 here. And then the denominator is just going to end up being 3. And then we just have to use our graph here to find f of 1. And this is the graph of f. So to find f of 1, we're just finding the value at 1, which is 1. So we get 1 times -2 over 3, and that would be my answer. But you need to have your work up above with L'Hopital's.